Hi, in our previous video, we did consider finding the true set of quadratic inequality, which is of the form ax squared plus bx plus c being greater than or equal to 0. That is what we did. In today's lesson, we want to consider how we can find the true set of quadratic inequality, which is of the form ax squared plus bx plus c is greater than 0. So that is what we'll be doing today, how we can find the true set of quadratic inequality of this form. Okay, so we can have an example like x squared minus 5x plus 6 is greater than 0. Now, how do we find the true set of this particular quadratic inequality that we are having here? Now, the first thing we have to do is to try and solve the quadratic expression. We change the quadratic expression to equation and solve for the two values that are there, and then we use the two values to do the testing. That is what we have to do. So we're trying to solve the two values. Yes, we can try factorizing that. When we get the linear factors, we try and then we use them. Okay, now how can we factorize this particular quadratic expression that we are having here, this particular quadratic expression? Yes, we go through the normal process. We take the constant, that is positive 6. Use that to multiply the coefficient of x squared, which is positive 1. Yes, so 1 times 6 is going to give us 6. You find two numbers which are factors of the 6, in which when you multiply you get 6, but when you add you get negative 5. Now for positive 6, we know that 2 times 3 will give us positive 6, but when we add, this is going to give us positive 5. But what we are having here, the coefficient of x is negative 5. So what we have to do is, the two factors, we have to negate them. The reason why we are negating them is, we know that negative times negative is positive. Negative times negative is positive. So we can use the negative 2 and the negative 3. Okay. Now the other factors, they are not going to work. When you take negative 6 and negative 1, yes, when you multiply them, negative 6 times negative 1 is going to give you positive 6. But when you add them, this is going to give you negative 7. So this can't work. Okay, so we are going to use these two numbers. Therefore, we are going to have our x squared minus 2x minus 3x plus 6. This is greater than 0. We take the first two, we factorize. What is the common factor there? The common factor there is x. So x comes out, we have x minus 2. We close the bracket. Take the next two terms there. How do we factorize that? The common factor there is minus 3. The minus 3 comes out, we open bracket. We are going to be left with x minus 2 being greater than 0. So we are going to have our x minus 2, that is the factor which is in the bracket. You have x minus 2. You pick one, then you pick the ones outside the bracket, that is the x minus 3. So this will give us x minus 3 being greater than 0. So this is the factorized form of the quadratic expression. After you getting the linear factors, you equate each linear factor to 0, because we want to solve to get the two values there before we can try and analyze that. So we are going to have our x minus 2 being equal to 0. We're going to get x being equal to 2. You take the other linear factor, the same thing. X minus 3 is equal to 0. You have your x to be equal to positive 3. Now these are the two values that when you solve that quadratic equation, you'll be getting. How do we find the true set of that quadratic inequality? Okay, so we try using the graphical approach or the normal line approach. So let's try using the graphical approach first. So the first thing we do, we draw our XY plane. So let's assume that This is our xy plane. We have our x-axis and we have our y-axis. We have our 0 here. Okay. And we have x being equal to 2 and x being equal to 3. So let's indicate these two values on the x-axis. So let's assume that we have our positive 2 here and we have our positive 3 here. This is not drawn to scale. All right, so we're assuming that this is how our OXY plane is going to be like. Now, the original quadratic inequality that was given, or when you consider the quadratic expression, it was what? X squared minus 5x plus 6. Assuming we are graphing this, the nature of the curve is going to be U-shaped, something like this. Or because the coefficient of the x squared is positive 1. Some will be thinking that yes, we don't have any number there. Yes, there is a number there, and that is positive 1. And anytime the coefficient of the x squared is greater than 0, when you graph that quadratic expression, you are going to get a curve that opens up like this. Yes. And this curve is going to pass through these 2 points, this particular point and this particular point. The curve will pass through these 2 points. So let's draw the curve. So we are going to have something like this. This not drawn to scale. All right. So we have our quadratic graph. Now the next thing is we're finding the true set. Let's analyze this. The inequality sign given was greater than. If it is greater than, then what we have to do is let's try and shade the part of the curve that is above the x-axis. So in this case, the part of the curve that is above the x-axis is what we are having here. So we can trace this down and we'll be having something like this. Don't forget that this can be shaded up to positive infinity. So assuming we want to continue shading, then we will shade up to infinity. You consider the side to the part of the curve that is above the x-axis. Are going to have this side. Okay. And this can be extended, but you have to trace that to the x-axis because it's the x values that we are interested. Okay. Now let's analyze that. If we are shading from positive 3 up to positive infinity, then the arrow is pointing toward the side. If that is the case, then we are going to have this inequality sign. So we are going to have x greater than 3. This time around, we are not going to include the 3 because we don't have the equal to sign there. Look at what we are having here. It was just greater than. It was not greater than or equal to. So if you don't have the equal to sign beneath that, you don't include the number that is there. If you have the greater than or equal to there, then it means that you have to include the number. So thus we are not going to include the number. That is why we have x being greater than 3. We are shading from this point, number 3, up to positive infinity with the 3 not inclusive. We come to the positive 2. We shaded the upper part. So when we trace to the graph, we have something like this. We are shading from positive 2 up to negative infinity. So we are moving in this direction. Once again, the inequality sign that we'll be using to define all the x values there will be this sign, and that is the less than. So it means that this particular one is going to be x being less than the number here, and that number is what? 2. So in this case, all x values that fall within this range, that is from positive 2 up to negative infinity, all these values will make the quadratic inequality defined. The same thing applies to x being greater than 3. All the values here, they are going to satisfy the quadratic inequality. And if you are talking about the true set, we deal with the defined values, the values that makes the inequality defined. So in this case, our truth set is going to be x is such that x is less than 2. So you pick this one. or x is greater than 3. You pick this one too. And that is the true set of this particular quadratic inequality. We can try the number line approach too. For the number line approach, now our quadratic inequality was x squared minus 5x plus 6 being greater than 0. And we did factorize this particular quadratic expression, and we had x minus 2, x minus 3. We did solve, and we had x to be equal to what? 2, and then x to be equal to 3. So what we are going to do is we are going to draw our number line, which is not drawn to scale. So let's assume that this is our number line. We have a 0 here. Let's say we have a negative 1. We have 1. We have 2. Let's say we have 3 also here. So what we are going to do is we are going to draw two vertical lines to pass through the two main values here, that is x being equal to 2 and then x being equal to 3, to get the three main parts there. So we have this, and we have, okay. Now in this case, what we are going to do is we have three main parts. So we have this part, we have the middle part here, and then we have this part also. We want to test the x values that are there, whether indeed they are going to satisfy the inequality above. So yes, when we factorize, we had x minus 2, x minus 3. Okay, so we have x minus 2, x minus 3 being greater than 0. So we are starting with the 2. When x is equal to 2, what is going to happen? When x is equal to 2, we are going to have 2 minus 2. We have 2 minus 3. This is greater than 0. Now 2 minus 2 is going to give us 0. So we are going to have 0 times what we are having here, 2 minus 3, that one too is going to give us negative 1. Is greater than 0. Now 0 times negative 1 is going to give us 0, being greater than 0. Now let's analyze this statement. 0 is greater than 0. Is it true or false? The statement is false. So it means that yes, when x is equal to 2, it can't satisfy the quadratic inequality. Now let's come and pick a value on the left hand side of the 2. So let's say we use 1 also to do the testing. Now when x is equal to 1, what is going to happen? When x is equal to 1, let's do the substitution using the same factorized expression. So we are going to have 1 minus 2. We have 1 minus 3 being greater than 0. 1 minus 2 is going to give us negative 1 times 1 minus 3, and now 2 is going to give us negative 2 being greater than 0. So from what we are having here, negative 1 times negative 2 is going to give us positive 2. So we have 2 being greater than 0. Now let's analyze this. 2 is greater than 0. Is this statement true? Yes, this statement is true. So this one, when x equal to 1, is satisfying the quadratic inequality. Let's try this one too, when x is equal to what? 0, and see. Again, when x is equal to 0, using the same factorized expression, we are going to have 0 minus 2 in one bracket. We have 0 minus 3 being greater than 0. Now 0 minus 2 is going to give us negative 2, multiplying 0 minus 3, and that is negative 3 being greater than what? 0. Negative 2 times negative 3 is going to give us positive 6. 6 is greater than 0, and this statement once again is also true. Okay, if that is the case, it means that the values starting from positive 1 up to negative infinity, all these values, they satisfy the inequality. And all these values are what? Defined values. Apart from x being equal to 2. So if you want to define all those values, then it's going to be x being less than 2. And as I said, if this side is satisfying the quadratic inequality, then definitely the other side too, this side too, is going to satisfy the condition. We can do the testing and check. So you realize that when we do the testing, this 3 is not going to satisfy the condition. But apart from the 3, all the values here, they are going to satisfy the condition. And it will be moving in this direction. Therefore, the inequality that will be defining all the x values will be x being greater than the x value there, that is 3. These are the defined set of values. And if you are talking about the truth set, we mean the defined set of values. Therefore, our truth set is going to be x is such that x is less than 2 or x is greater than 3. This is the truth sets of the quadratic inequality. Let's try another example. Find the truth set of 6 minus 5x minus x squared being greater than 0. So the first thing we have to do is to solve and get the two x values in there. Then we can use that to do the testing. Okay, so I would like us to factorize this particular quadratic expression, and then we can continue from there. You can decide to solve this quadratic expression and change it to equal to sign so that it becomes quadratic equation, and then you solve for your x. So we are going to have the constant, which is 6, and then the coefficient of x squared is -1. When they multiply, this is going to give you -6. We want two numbers in which when you multiply, you get -6, but when you add, you get -5. And this is going to give you, or you are going to have -6 and then +1, satisfying that condition. Because -6 times 1 is going to give you -6. But -6 plus 1 is going to give us -5. So in this case, we are going to have a 6 minus, we use this first value, so minus 6x. Come and use the second value, so plus 1x. Then we bring the last term, that is minus x squared. This is greater than 0. We factorize the first two terms. What is the common factor there? 6. So 6 comes out. We are going to be left with 1 minus x. We close the bracket. We take the next two terms. The common factor there is positive what? X. You open the bracket. We are going to be left with 1 minus x. You close the bracket. Greater than 0. So the next thing you do is, yes, 1 minus x is common. So this is going to give us 1 minus x being in one bracket, and then the ones outside, that is 6 plus x. You have 6 plus x being in another bracket, and this is greater than 0. We are solving for the values, so let's change this to equal to sign. So we are going to have a 1 minus x in one bracket, 6 plus x in another bracket being equal to 0. We solve for the two values, so 1 minus x, we equate that to 0. That we take each linear factor, then we equate it to 0. And this is going to give us 1 being equal to x, which is the same as x being equal to 1. We take the other linear factor, that is 6 plus x, we equate it to 0. We get our x to be equal to -6. Therefore, the two x values are 1 and -6. Sorry, this side is -6. Okay. All right. So we want to find the true set. And how do we find the true set? by either using the graphical approach or the number line approach. So we want to use the graphical approach. When we are done, then we try using the number line approach too. So for the graphical approach, we are going to draw our OXY plane. So let's assume that this is our OXY plane. So we have our X, we have our Y, we have our 0 here. So let's assume that the positive 1 is here. And we have our negative 6 also here. This is not drawn to scale. Okay. The quadratic inequality was 6 minus 5x minus x squared. Now we want to graph this. Without we going through the normal process, we can use the coefficient of x squared to get to know the shape of the graph. The coefficient of x squared is -1. If the coefficient of x squared is negative, then it means that when you draw the graph, it's going to be something like this. That's anytime the coefficient of x squared is less than 0, that is negative. So in this case, we are having the coefficient to be -1. So the curve, as we said, the curve is going to be like this. And also, the curve is definitely going to pass through these 2 points, this point and this point. So we are going to have something like that. This is not drawn to scale. So okay. Now, what we have to do, we have to consider the inequality sign. It was greater than 0. So you drawing your graph, what you have to take note of is this particular sign, that is the greater than sign here. The implication is shade the part of the curve which is above the x-axis, and it is this part. This part is the part of the curve that is above the x-axis. And since we are doing that, we want the x values that are there. So let's trace it to the x-axis. Okay, this is the part that is above the x-axis. If that is the case, then it means that the values within -6 and then +1, these values satisfy the quadratic inequality. Those values make the quadratic inequality there defined. And if we are talking about the true set, then we want the defined values. The values that make the quadratic inequality defined. So -5, -4, -3 up to 1, with a 1 not being part of the values. So in this case, it means that the values, they are what? Greater than -6. So x is greater than -6, and at the same time, the x values, they are less than 1. So x is also less than 1. If that is the case, we combine these two single inequalities. Or what you have to know is, if we want from -6 up to +1, with -6 and +1 not being part of the values, then we are going to have -6 is less than x less than 1. You can pick any values in here, then you try and substitute that into the quadratic inequality to check whether it's going to satisfy that. So that is our truth set. And thus x is such that -6 is less than x less than 1. Let's try the number line approach. For the number line approach, let's assume that this is our number line. And we have, let's assume that we have our 0 here. We have our -6 here. And we have our +1 here. What we are going to do is we are going to draw two vertical lines to pass through these 2 points. So we are going to have it like this. Okay. So we have 3 parts. This part, the middle part, and then this part. The quadratic inequality was 6 minus 5x minus x squared being greater than 0, and it was factorized, and we had 1 minus x and then 6 plus x being greater than 0. Okay, so what we are going to do is we are going to test using this same factorized expression, that is the 1 minus x 6 plus x being greater than 0. Now let's start with the negative 6. When x is equal to negative 6, what is going to happen? When x is equal to negative 6, we're going to have 1 minus negative 6 plus negative 6. This is greater than 0. 1 minus negative 6, this is going to give us positive 7. Negative times negative is positive, so this is going to give us 7. And then this side is going to give us 0. 6 plus negative 6 will give us 0. 7 times 0 is going to give us 0. So we have 0 being greater than 0. Let's analyze this statement. Is it true or false? 0 can't be greater than 0. So this statement is false. It means that negative 6 can't satisfy this particular quadratic inequality. So what we have to do next? If that's the case, let's pick another value from this side. And see, let's say negative 7. So when x is equal to negative 7, what is going to happen? So we are going to have, once again, 1 minus negative 7. We have 6 plus negative 7. This is greater than 0. Now 1 minus 7, this is going to give us positive 8. That is 1 plus 7. So this will give us 8. And then 6 plus negative 7, this is going to give us negative 1. And this is greater than 0. From what we are having here, 8 times negative 1 is going to give us negative 8, which is greater than what? 0. Let's analyze this. Is this statement true or false? Negative 8, it's not possible that negative 8 is greater than 0. So this statement too is false. If that is the case, it means that all the values from negative 6 up to negative infinity, they can't satisfy the quadratic inequality, so they are all false. They make the quadratic inequality undefined. Okay, if that is the case, if this side is false or undefined, then definitely this side too is going to be false or undefined. You can do the testing when x equal to 1. When x equal to 1, what is going to happen? So let's use the same factorized expression. So we are going to have 1 minus 1. We have 6 plus 1 being greater than 0. 1 minus 1 is 0. 0 times 6 plus 1, which is 7. This one too, the same thing. We're going to get 0 being greater than 0. And this statement is false. That's why we are saying that all values from 1 up to positive infinity 2 is going to make the quadratic inequality false or undefined. Let's pick a value in this side, that is the middle part here, and use that to test and see. Let's say when x is equal to 0. Now when x is equal to 0, what is going to happen? We are using the same factorized expression. So 1 minus 0, we have 6 plus 0. And this is greater than 0. 1 minus 0 is 1 times 6 plus 0, which is also what? 6 is greater than 0. from what we are having here, 1 times 6 is 6. So we have 6 being greater than 0. And this statement is true. This statement is true. That's why we are saying that values within here, they satisfy the quadratic inequality. They are all true values. They are all defined values. So values within -6 and +1, they satisfy the quadratic inequality. Therefore, you writing an inequality to define the range of values there is going to be -6 is less than x less than 1. So the truth set is going to be x is such that -6 is less than x less than 1. So this is the truth set. This is where we are going to end today's lesson. But I want you to try this question on your own. That is, you finding the truth set of y squared minus 6y is greater than -8. I want you to try this question on your own. See how you can find the truth set of this. But don't forget, the first thing you have to do, let me give you a hint, the first thing you have to do is to rearrange that in the standard form. So you'll be having your y squared minus 6y plus 8 is greater than 0. Okay, I will pause here. In our next video, we are going to consider the quadratic inequality, which is of the form ax squared plus bx plus c being less than or equal to 0. Don't forget to watch out for that video. Thanks for your time.